This is our last and final video of our energy in chemical reactions unit. This is for assignment number 9, and these are the only notes you are taking for this assignment. So there must be enough kinetic energy in the reactant particles when they collide to break bonds. So bond energy is the energy required to break the bonds in a chemical reaction. Now we know that there are two different types of chemical reactions. We have endothermic and exothermic. In an exothermic reaction, bonds are formed because energy is released, it's given off. So the energy released to form bonds is greater than the energy absorbed to break the bonds, because in a chemical reaction, you both have to form and break bonds. But in exothermic reactions, the energy releasing from the bonds is so much more that it makes it exothermic. The other type of reaction we know of is endothermic. Endothermic reactions, bonds are broken because it requires energy to break them apart. So when the bonds are absorbing energy, when they hit each other, then they can split apart. So the energy absorbed to break bonds is greater than the energy to form them. Again, like you have to form and break bonds in a chemical reaction. To get an endothermic reaction, the energy absorbed has to be significantly more. So if we take a look, we have exothermic reactions. We know forming bonds releases energy. This makes the products more stable. Lower energy makes them more stable. So you can see before, we have our two molecules, and then the yellow represents like during. So there's energy leaving. I really hope you heard that, because that was my cat screaming at me. I'm in the middle of something. So energy leaves, and then after they are bonded together. So this, they have a higher energy, after they have a lower energy. And like that looks like our exothermic graph, right? If we were to graph that, it would look like this, which we know releasing energy. So at the end of the reaction, there's less energy than at the beginning. So having a higher energy before and a lower energy after makes sense when you form bonds, because the energy is leaving. Now, for endothermic reactions, you need to have more energy that's being absorbed. So this will allow you to break bonds. So if you look at the picture, we have our like two molecules, let's say. As energy go in, they're going to like collide with each other. So they get the energy from colliding with each other, they absorb it, and then that causes them to break apart. So you can see the after, like they're all individual. So before the reaction, before they collide and hit each other, they're at a low energy. And then afterwards, after they absorb it, they're at a really, really high energy. So our endothermic graph, we know, starts low and ends high. Our reactants are lower than our products. So it makes sense that we have a lower energy to start, and as they absorb and break their bonds, our products are going to have a higher energy because they absorbed it all. Okay. I would copy these pictures down in any space that you have, or ask me for another piece of paper. But yeah, so exothermic forms bonds by releasing energy to make it more stable. Endothermic absorbs energy so that it can break bonds. And then as a result, the products will have a higher energy.